been factoring polynomials, we've been finding our zeros, we've been deconstructing everything. So today we're going to look at how to start putting it back together. All right, and this is going on page 59 when we're done. And the directions say, write an equation that could represent the function with the given zeros. All right, so we're going to skip around a little bit. We're going to start with number 3. Okay, so because if you can do number 3, you can do numbers 1 and 2. Those are super easy. These are my zeros that they're giving me, right? And so to write an equation, you have to understand where your zeros are coming from, right? So like since this is -2, that would mean that x equals -2, so x plus 2 equals 0, right? So my actual factor in here is x plus 2. That takes care of this one, right? Then I have this -4/3 and this 2. Well, these kind of go together, so I think I'm going to put this one next. So what's that one going to look like? X minus 2. I got that one taken care of. So then that -4/3, is that going to be x plus 4/3? No. That is going to be what? 3x plus 4. Okay. So we've written it out. Now we've got to multiply things together. These two right here together, is that a special case? Difference. So you can fill it out if you want to, but it's a little bit of a waste of your time because you should know these things by now. And this would just give me here x squared what? Minus 4. And then this is 3x plus 4. Okay. So then I have to FOIL this. 3x cubed plus 4x squared minus 12x minus 16. Then I would combine like terms and clean it up if I can, but there's nothing more I can do there. It's already in order, and I'm done. Okay? Everybody okay with that? Any questions at all? All right, so I want you to look back up at the directions. The directions say, write an equation that could represent the function with the given zeros. So I want you to think about how that's worded versus how things have been worded for most of what we have done so far. And I don't mean about specifically what it's asking you to do, just the general wording of the question. What kind of stands out that's a little different? It could, right? This word could here, what does that imply? It could be more than one answer, right? And so this is an equation that could represent a polynomial with these zeros. This isn't necessarily the polynomial that they intended. And why not? What could be different if these still have to be my zeros? Okay, so she said it could be like x plus 2 squared. That is a possibility, and especially thinking that without me giving you other information. If that is the case here, they will tell us that though. But that is a good thought. When you have something completely factored out and you go to start finding your zeros, what in the factored form is not going to affect what your zeros are? A number on the outside. Like after I have this, I have no way of knowing if there's supposed to be a GCF that's not a variable out front. There could be a 3 that I factored out. There could be a -72 I factored out. There could be a -1. We don't know, right? So there could be a negative here which would change my end behavior, right? And there could be a number here would also change the shape, but neither one of those things would change my zeros. So without more information, this is the best we can do. All right. They could possibly give us the y-intercept, and that could help us with some other things. But this is what could represent, and that's all we're really expected to do at this point anyway. But that's why it's worded that way. So wording like that, you want to pay attention to. Sometimes that can help you figure some other things out too. All right. So let's look at number 4, but we're not really doing number 4. I'm going to kind of change. We're going to do number 5, but do it over here. So we're going to mark that out, and we're going to have plus or minus 2 squared of 3, and then plus or minus 1. Okay, mark that up there. So f of x equals, and this is plus or minus here, so I'm going to have x plus 2 squared of 3, x minus 2 squared of 3, and x plus 1, x minus 1. We agree with that? We've got our factors written down. These two together give me what kind of situation? Is it going to be a difference of squares? It is. I mean, you can FOIL it out and figure it out, but you don't even need to do that. So this is going to give me x squared minus, what's 2 squared or 3 squared? 12. You all agree with that? Yes. 2 squared or 3 squared is 12, because you're going to do 4 times 4 is, no, I'm sorry, 2 times 2 is 4, square root of 3 times the square root of 3 is what? 3, so 4 times 3 is 12. If you do this on the calculator, you're most likely to type that in, and it'll give you 6, and you'll think it's right because it's the calculator, and it must be right, but no. So be very careful with that. It is 12. Because if you simplify 12, you get 2 squared of 3. And then this is also a difference of squares, so this is x squared minus 1. Then can we multiply those together? Yes. This is going to give me x to the 4th minus 13x squared plus 12. Okay. Everybody okay with all that? Any questions? All right, so now we're going to do number 6, but we needed more room, so I wanted to have plenty of room. So this is actually going to be number 6 here. And so my f of x is going to be equal to, what's this first thing going to give me? X plus 6. Right. And because this is really x minus a negative 6, right? So we always start off with x minus whatever the 0 is, and then since it's minus a negative, that's where it becomes plus. So here I have 2x plus the square root of 5 and 2x minus the square root of 5. So if this is x minus 2 plus the square root of 5, can I just write it in there like that? What do you have to do every time you substitute in something with more than one term? Parentheses. So there should be parentheses here. They matter big time. And then I would also have x minus 2 minus square root of 5. Everybody with me so far? This is a case where you do not want to distribute that negative. That is not how we're going to handle that. That'll just make this 10 times harder. What we are going to do, though, is just go ahead and rewrite this, because he's just going to hang out for a minute. So this is going to be equal to x plus 6 times. And then I'm going to need to take care of these two. So when I multiply them, I'm going to FOIL them. I'm going to treat this just like x minus a times x minus b. Same exact thing, just that this would be like my a term and this would be like my b term. So I'm going to have brackets here because I have lots of parentheses. My first term, x times x, is going to be x squared. I didn't need the parentheses there. X squared. My outside 2, when I multiply x times a negative 2 minus the square root of 5, is going to be minus x times 2 minus square root of 5. Then I do the inside 2, x times this term, so that's going to be minus x times 2 plus square root of 5. And then I got to multiply the last two together. They're both negative, so that's going to be plus 2 plus square root of 5 times 2 minus square root of 5. So make sure you understand where everything came from. Ask me a question if you got a question. There's nothing difficult about this. It's just tedious, and you got to make sure that you're writing everything down, you're not skipping steps, and that you can read your own handwriting, okay? And that you know how to multiply. All right, so I'm going to come in here. I'm just going to rewrite this x plus 6 again, and I'm going to clean up what's in here a little bit. So x squared, there's only one x squared, right? Then I'm going to go ahead and distribute this negative x now. So this is going to give me negative x times 2 is going to be minus 2x. Negative x times negative square root of 5 is going to be plus x square root of 5. Then distribute here. I'm going to get minus 2x. Negative x times square root of 5 is going to be minus x times the square root of 5. Plus, then I've got to multiply these two things together. What kind of thing is happening there? It's what? It's the difference of squares. Because this right here is like having x minus, or x plus a times x minus a, right? It's just like, it's the difference of squares, just like we had done before, yes? Just like right here, okay? So all I have to do is take the first term and square it. That's going to be 4. And then minus the second term squared. What's the square root of 5 squared? 5. Square root of 5 squared is 5. And then we have that. Okay? Then I'm going to go back and clean it up some more. So this x, there's only one x squared, so this is just going to be x squared. Then minus 2x and minus 2x is going to give me minus what? 4x. And then plus x squared of 5 minus x squared of 5. What happens with that? Those cancel out. That's nice. And then plus 4 minus 5 is going to give me minus 1. Okay, everybody good? Then you should be able to multiply that out. Okay, so go ahead and finish that up. Do y'all agree with that? Any questions? All right. So just because things get ugly looking doesn't mean that it's crazy hard. You just got to be able to keep up with what you're doing. Watch your signs, because those kinds of things are going to kill you here. All right, so let's look at some examples with multiplicity. We are going to do number 8. So I have f of x equals. So when I go and put my factors in here, what do I do with that 0? It's just x, right? Because it's like x minus 0, which is just x. And then that 1 is going to give me x minus 1. And then this has a multiplicity of 2. So what does this look like inside the parentheses? 2x minus 5, and since squared because the multiplicity is 2. Okay, does that make sense? Now, if you need to write out 2x minus 5 times 2x minus 5 to see it that way, I mean, you can if you need to. You need to get past having to do those sorts of things. But when I get to this part here, am I just going to square this one and square this one? No, only if you want to be guaranteed to get it wrong. So I'm going to multiply these two together and get x squared minus x. And then when I square this, okay, I square the first one, so 2x squared is 4x squared. And then I multiply the two of them together and do what with it? Times 2. So 2 times 5 is 10, so this is going to be a negative 20x. And then I square the last one, plus 25. It's your perfect square trinomial. Knowing some of those knowing how to multiply this is way more helpful than knowing how to factor that one. Like, it helps both ways, but knowing how to multiply it and what to do quickly is good. Then I can multiply the rest of that out. So go ahead and finish this up. When you're done, make sure you agree with me. Ask me questions if you have questions. All good? All right. So look at the back. We're going to do number 9. So on number 9, I have the f of x to be equal to this negative 1 is going to give me x plus 1. So that multiplicity is 3, so that's cubed. Times, what is the next one going to look like? 4x minus 5. Okay. So this x plus 1 cubed, is that the sum of cubes? No. Sum of cubes would look like this. Those are two completely different things. So be careful with that. There's not any little trick here. Okay, no shortcut, nothing like that. So in this case, I would suggest you split it up, not completely necessarily, but make it like x plus 1 squared times x plus 1 times 4x minus 5. That way you can take care of this and then that and then put those together, right? So x plus 1 squared, when you have a perfect square trinomial, you square the first term, you multiply the two together, and you double them. So that's going to give me plus 2x, and then you square the last term. Looks like that. Then we should be able to FOIL this out correctly. 4x squared minus 5x plus 4x, so minus x minus 5. Okay, everybody good with that? So go ahead and finish that up on your own without watching me do it. Because you got to be able not only just to factor, but also to multiply everything back. I would suggest when you have a bazillion terms like this that you mark them somehow when you go through to combine them so you don't forget something or use something twice. So I only have one x to the 4th term. So I got 4x to the 4th. I have 8x cubed minus x cubed. Those are the only two, so that gives me plus 7x cubed. Then I have a 4x squared and a negative 2x squared, which gives me 2x squared. And then minus 5x squared would give me a negative 3x squared. Then I have a negative x and a negative 10x, and minus 11x, and then minus 5. Okay, questions? All right, so let's talk about the conjugate root theorem, right? Conjugate root theorem. So if a polynomial function has a complex 0 at a plus bi, where b does not equal 0, right, then its conjugate, what would its conjugate look like? A minus bi, good. A minus bi is also a complex 0. Which means that you may be given an incomplete list and you have to know that it's an incomplete list. All right, so we are going to, let's see, we'll do, I don't know, y'all want to do 12 or 13? 12? Okay, we'll do 12. That's fine. Because we don't need to do both of them. We're going to do this one, then we'll do 14. So on 12, I have these two as my zeros, and then I also have 2i. Which means there's something missing. What's missing? The conjugate of the imaginary one. So what would the conjugate be? Minus 2i, so negative 2i. Okay, a is 0 there basically. So that one is part of it too, even though it's not in my list. I have to know that. So then I can start putting this together. F of x is equal to, so the square roots here, I've got x plus the square root of 6 times x minus the square root of 6. And then I have x plus 2i and x minus 2i. Really, x minus 2i comes first. It doesn't matter. I just always put my positive ones first for whatever reason. Then when I go to combine these, what kind of situation do I have going on here? Difference of squares. So this is just going to give me x squared minus, and then square root of 6 squared is 6. What kind of situation do I have going on here? Difference of squares. So I get x squared minus, and then what is 2i squared? Okay, my question is, what is 2i squared? And it is negative 4, right? Because 2 times 2 is 4, I times I is what? Negative 1, so that gives me a negative 4. That's what has to go in here. So because it's always x squared minus, and since it's a negative 4, that becomes plus 4 right there. Okay? Make sense? We good? Watch your signs when you got your imaginary numbers going on. All right, then multiply. Go ahead and multiply these out. Everybody okay with that? Yes. All right, so we're going to need some more room for 14, just like we did on the other one. So we are going to just mark out this one. We're just not even going to do this one. And we'll start 14, like over here. Now, I have negative 4 as a 0, and 3 plus I is a 0. Am I missing anything? 3 minus I. Should I also have a positive 4? No, doesn't work that way, right? So that's what was missing. So now I can come over here and put this stuff in. I get f of x is equal to x minus a negative 4. That's where my x plus 4 comes from, right? And then I'm going to have x minus 3 plus I. What do I have to make sure I do? Parentheses. And then times x minus 3 minus I. Okay, everybody with me? All right, so I want you to try and go ahead and FOIL this out. Just get to the next step without watching up here and stop, and then we'll make sure we agree before we move on, because if you're missing something, I don't want you to keep going. All right, so are we all right here? Do we agree with this? If you have these two terms flipped around, that's fine. It's the same thing. It doesn't matter. I just literally did the outside then the inside. But okay, are we all good before I move on? Okay, so now go ahead and distribute that and clean this up in here a little bit. Oh, wait. Y'all agreed with me and something's wrong. What's wrong? No, what's wrong in this step? I just caught myself as I was rewriting it. Yes, this should be plus right here because this is negative times negative. That should be plus. Y'all let me down. I didn't say copy mine down. I said, do you agree with me? So if the answer is no, you got to let me know. All right, so this should be plus right there once I get to this point. So then what is this little situation called? Difference of squares again, right? It's a difference of squares. If not, you'd have to FOIL it. And there'll be times where you might have to FOIL something like this, but it's a difference of squares. So I can square the first one, which would be 9, minus, I'm going to square the last one, and even though I know you know what it is, I'm going to write it like this for a reason, I squared, right? We'll fix that in just a minute, but making sure we can think about how these signs work. All right, so then this gives me x plus 4 times x squared. So I have this negative 3x and negative 3x is minus 6x. These two cancel out. That's nice, right? They're gone. Then right here, this is actually 9, and then what's I squared? -1. So that's minus a -1, which is really plus a positive, so this is plus 10. Okay? Everybody okay with that? Then go ahead and multiply this out without just following me. And then let's make sure we agree. Any questions at all? All right. Should be nothing complicated about what we're doing right now. It's tedious, and there's lots of room for mistakes, right? Sign errors, other little things. So be cautious in what you're doing. Don't be stubborn and try and skip a bunch of steps, because you will regret it, all right? Any questions at this point? Awesome. Go ahead and glue them in.